All right, now let's talk about parallel circuits. A little more complicated with a parallel circuit because now instead of one pathway, there is more than one pathway for current to travel through the circuit, right? So in series, we only had one way for the electrons to get from the negative back around to the positive. Well, now we've got multiple pathways. You'll notice right off the bat, these look more complicated because they are. And there are places where there are junctions. We have choices now. The electrons have choices. So let's go ahead and talk about and count. You go ahead and count before I do this. How many pathways are there in this circuit for the electrons to get around from the negative to the positive? How many pathways are there? Pause the video and count them. All right, let's look and see. Here is pathway number 1. There's pathway number 2. And there's pathway number 3. Now, you need to write some things down. It wouldn't be a bad idea for you to draw this circuit in your notes. A few terms you need to know about with parallel circuits specifically. This little pathway right here, we're going to call that the main line. And the reason we call that the main line, I'm hoping you notice that as we draw these pathways, the main line is the one part of the circuit that is common to all possible pathways in the circuit. And there's an important significant result of that we'll talk about in a second. But we call that the main line. All the red, the green, and the blue pass through this wire, this part. And then these ones over here are simply called the branches because they branch off of that main line. Now notice, I'm not going to call this the main line because it doesn't include all pathways. There's 2 of the 3, but it's not all of them. It's just the part that has all pathways, that all pathways run through that one wire. That's called the main line. The thing about a parallel circuit that gets interesting is that as long as we don't have a break on that main line, I can break the current anywhere, break the circuit anywhere else, and it's not going to affect the other resistors. And the reason is because they all have their own direct path to the battery, as opposed to a series circuit. Let's go back and look at that one. Nope, not that one. With a series circuit, before the current gets to the 10 ohm resistor, it has to go through this 20 ohm resistor first. Therefore, the 10 ohm resistor does not have a direct pathway to the battery. But when I look at this one, each of these resistors does have a direct path to the battery. The current can go straight to R1 before it gets to anything else. It can also go straight to R2. It doesn't have to pass through R1 before it gets to R2. Same thing with R3. So they all have their own direct path, their own direct connection to the battery. So if I cut the main line, that means all of these are going to be out. All of these are going to be gone because I have cut all of the pathways. I have opened the red pathway, the blue pathway, and the green pathway for current. However, if I just cut R1, I've just cut R1. The blue pathway for R2 is still fine. The green pathway for R3 is still okay. Same thing if I decided to cut R3. R3 would go out, but R2 and R1 would still be the same. R2, cut it. R2 is done. These other 2. Now, what's interesting is if I cut this one right here, again, this is not the main line, but I have cut 2 pathways simultaneously. So if I cut here, R2 and R3 will go out. In other words, everything downstream of that will go out, but R1 will still be okay. Let's look at this. So I've constructed a simple parallel circuit here with a switch involved. It was the same switch from a previous video. The first thing you should notice is that it's more complicated. It looks more complicated in a diagram. It looks more complicated in real life. So I got my batteries here, negative side, positive side. Maybe I should have the switch hooked up to the negative and positive, but here's the point. Let's trace the pathways. From the negative side, pathway number 1 goes through this bulb. So we're going to go in here, through the bulb, and then it can go directly back to the battery. Here's the pathway back to the battery. I can bypass this bulb and go back to the battery, bypass that bulb and go back to the battery, through this switch back to the battery. All right, and turn the switch on, we can see that all the bulbs light up. You can probably see it better with the lights off. Right, so all the bulbs are lit right now. If I look at pathway number 2, again, this is a main line. This is a common pathway. So we can actually, at this point, there's a choice now. we can bypass this bulb and go through this wire in here to bulb number 2, go through bulb number 2, and then through the green wire, bypass this one, and go back to the battery. All right? Or I can take pathway number 3 from here, branch point. I can now go through this other yellow wire through here, which bypasses this bulb and goes directly to the third bulb. After it goes through the third bulb, it will again run back to the positive side of the battery. So there's my 3 pathways. And the consequence of that is if I break the pathway anywhere in the main line, which is common to all of them. So you might have noticed I used this black wire on all of them, and I use the red wire which runs through the switch on all of them. So this is our main line. If I break the main line, which is what the switch is doing, this switch is on the main line. So if I break the main line, everything goes bad because I've broken all the pathways. I can bypass this switch. If I break the main line here, they all go bad. Break the main line here, they all go bad, but there's our switch. All right, usually you put switches on the main line. Now, I'm going to bypass it again so that I can do this. Remember, the cool thing with parallel is if I break anywhere else, as long as that break is not on the main line, we're okay. So focus that a little bit. So let's say I unscrew this bulb. That breaks this pathway. But notice the other 2 are still okay because the other 2 still have their own direct connection to the battery. It goes through here, through this bulb, this way, through that bulb. The only pathway that got broken was this one right here. Same thing. If I can unscrew this bulb, it doesn't break the other 2. So there's a fundamental distinction. There's a fundamental difference here with a parallel circuit and a series circuit. Remember, in series, if I got rid of one of them, all of them went bad. Now that's not the case in parallel. It's much more complicated. In order to get all of them access to the battery, direct access, so that they don't have to go through another one, multiple pathways here. And so they will all operate independently of each other. Now, I want you to remember this because as we go on, and especially toward the end, there's going to be some really important fundamental results. There's going to be some good value we get from this because of a parallel circuit. Now, I know I talked about parallel circuits Christmas lights in regard to series circuits before, but Christmas lights, remember, as I said, are actually parallel circuits. There are several series circuits that are arranged in parallel, right? So I've got all these parallel circuits that each of these individual pathways have a direct connection to the power source, right? So to go to this particular strand right here, the current does not have to go through this strand before it gets here. It can go straight to, well, this way. It can go straight to this strand. It can go straight to the third one, straight to the fourth one. So if there's a bulb that breaks on this one strand is out, but the rest of them are going to be fine. That's the reason why you'll find with Christmas lights, part of the strand is out while the rest of it is okay. Now, part of the problem here happens when we put lights on the street and the whole end of the strand is bad, the entire end of the strand. Well, probably what happened here is we broke the line at this point. It's not a main line, but that pathway is common to these last 2 pathways, in which case both of those last 2 parts of the strand are going to be bad. They're going to be inoperational. Again, that's an open circuit with these 2 parts of the pathway. All of these bulbs are just fine, but we got to find out where that break is to get them going again. So that's kind of an introduction to basic parallel circuits.